Good. This is off one of our multiple choice exams. This is a differential equation. Okay, Zach? And it says the rate of change of the volume. I think the reading is the hardest part of the exam, honestly. What is the rate of change of the volume? V dt. Okay, so while we're doing this, because now yes, we have a test, but also, I know it's not going to be A, it's not going to be B. You have to have a dV dt in it. So that's just good test-taking skills. And it says, with respect to time, are these all time? Yes. Is directly proportional, which means it's a product. It's multiplying some constant times the square, not the square, the square root, not the square root of the volume. So it's not the square root of the time. It's not inverse. This is inverse here. So it has to be E. Yes, D is the inverse. If they said inversely proportional, it would be D. Easy to make a mistake. Is directly. If they had said inversely, you would have chosen D. It's not A. Oh, well, it's some constant. You can call it anything you want. Okay. Now we're going to do the logistic growth. And we're going to go over these questions. And not be too long. It's not that hard. It's that it's new. Okay, Zach, you should probably have your handout out. Given that the population growth of bacteria is proportional to the population, write a differential equation. So what am I going to write for that? The growth of the bacteria, because they could ask you that. You want dB? dt is directly proportional to the population. So it's K times B. Now, what part of this gives you the population growth rather than decline? Okay, what gives you growth? The fact that K is positive. That's the growth factor. This is a review, some of it. It pretty much, I've talked about this, and these problems shouldn't be too bad. However, you got to be prepared for a free response question, so we will do that. You will for sure have multiple choice, and you have a sample of multiple choice, and they're not so easy. You might think they're easy, but some are harder than others. Some are really easy. When can I use this model of population growth? Nick, when do I get to use this? Let's change color so I can see it. When the population is small. Why? What happens when the population gets big? It will look like this, and we can't have that happen, but why? You're right, it's going to plateau, it's going to do this. Okay, put the phones away in the back. This is called, this is logistic. Carrying capacity. What happens if the population gets too big? Something's going to have to happen. Population has to decline. I like that. Because not enough resources. Okay. If the population gets too large or exceeds its carrying capacity, what must be true about the population growth? dP dt has to be what? No, population is going to decline, so this must be negative. Okay, David? If the population gets above the carrying capacity, which is be up here, so if it does this, it's got to come back down. So what's true about the slope? It's going to have to switch over to negative. Yes. Sorry, I would have preferred P, but or dB dt for bacteria. There. What's true if the original population is 0? dB dt equals 0. What if the population reaches its carrying capacity? What should be true about the growth? Now, this is assuming we're coming in like this, What should be true about dBdt? That's right. That should also be 0. Remember what these are called? Starts with an E. Equilibrium. Okay, we started with population growth in this chapter, and we're ending with it. Here's what you must know. You must know this equation right here. This is the logistic equation. I will tell you what the solution is, but you don't have to know it. So don't bother with it. This is the logistic equation. Now be careful, because these are not T, but P. If I put a T in there, it's not logistic. What has to happen is, if it's logistic, if I cover up this side right here, then dP dt would equal your growth factor times P. This is for small populations. But what happens when P gets to be greater than K? What happens to that? If that's bigger than K, what happens to my derivative? It becomes what? Negative. So population has to decrease so it reaches equilibrium. Okay, the phone should be put away. This is our last lesson. Then after this, we review. This week's a crazy week, and then we only have 2 weeks to prepare for the exam. If this is bigger than K, this is still positive, but this factor becomes negative. They're fighting each other. Okay. It's just dP dt equals Kp. That grows without bound. Yes. Okay, girls. Hey, Bjorn. Okay, any questions with that? You have to know that formula because you're going to see it on the exam. Okay, Nick, put your phone away, please. Put it away. We're doing this. Okay, here's a problem. Let's draw the slope field for this. I can get my calculator out. I've seen this on several problems, actually. And it says my calculator window should be 0 by 100 and 0 to 1500. And I can even remember the equation that is like that. If you have the Euler equation program on your calculator, then you can do this, the second part of the lesson. I don't have it, so I can't do it. Okay. That's what I want to type in. So program, slope field is 4. I forgot to change my window. Okay, let's do the window. Oh, it's not going to let me do that. Okay, window. I want 0 to 100. Now, do you know that you can turn the tick marks off by putting a 0 there? Okay, you guys in the back, you're supposed to be doing this with me. And I want my y's to be what? 0 to 1500. I'm turning off. You got to do your window first on this program. I'm going to turn off the scaling so that I don't see all those scales. Well, maybe I do want it in there. Let's put 100 here on the y's at least. Okay, ready? Now, we're going to quit. My program is still running, even though I've escaped from it. If I press enter, it will go right into the program again. So, now I got to type this in. This is y, so it's 0.08 y. How do I get y? We press alpha, and the y I think is here. No. Alpha and the y is above 1. Parentheses, 1 minus y over 1,000. You have to use the alpha key. You have a calculator? No. Okay, girls? Are you ready for this? No. No, it's taking the y1. It's taking the y coordinate. I don't program it. I'm just telling you that's the same as y1. No, I didn't program this. So we press graph or enter, not graph. There's the slope field. Well, I'm not surprised at it. Oh, that's a nice slope field. Take the big one. Okay, P of 0 is 0. That's starting here. Where is that going to go? Not if your population is 0. Okay, what if my population is 400? I did by hundreds. 1, 2, 3, 400. Follow the slope field, and now it's going to bend like that. And we can do a problem that's just like this. I have it up on another slide. And the population of 0 is 1,300. This was 1,000, right? 11, 12, 13, so I'm going to start here. That's the slope fields. Is that okay, John? That's it. That's it. That's all there is. You can do this with Euler if you want, but I'm not going to. Let's look at 2004 question 5. Do you have that in that packet? You have part of it. No, you might have it. You have it. There it is. It's on the back of the gold sheet. Now, your logistic equation must be in the right form. I'm going to give you a chance to work on it, but look at this. This is the logistic one. Okay, everybody pay attention. Okay, you guys? Because this is probably going to be the double bubble problem, and you don't want to lose the points on this. This is that the same? Look at it carefully. Are these the same equations? No, this is not logistic. You know how else I know it's not logistic? Tells me it's separable. Okay, Bjorn? The logistic, these have to all be the same. They're all going to be the y or the p in this case. This one, they're not. I was looking for logistic right here, but no, it changes to t over there. It's a separable differential equation. That's like a regular one, yep. So you can answer A, B, and C really quickly. I don't need to solve that equation for P. It's somewhere in your packet what it is. I don't even want to show it to you. It's here underneath the Euler thing. There it is. That's the equation, but who cares? Don't memorize it. I don't even want to show it to you. Okay, guys? David, what's the answer to A? If P of 0 is 3, what's the limiting value for my population? That's what we're doing, A. That's why you need to be paying attention. This is the logistic equation, which looks like the PDT is equal to my growth factor, which is 1/5 P, and it's 1 minus P over the carrying capacity. What's the carrying capacity? 12. What's the limiting value? 12. You can't believe it's that easy, can you? It doesn't matter where you start. What's the limiting value? It's the carrying capacity. It's 12. Well, you kind of, if you learn it, and you hope that there's one. Okay, you guys ready? Now, what's the value of the population when the population is growing the fastest? It's 6. Now, this year, all they did was require that you say 6. Other years, they've had you actually find the second derivative. If I wanted to be safe, I'd find the second derivative, set it equal to 0, and then I'd have 6. Now, the rest of this is the AB part, solving that differential equation. Separate the variables. So dy dt equals, I'm going to make that 1/5 times y, and then it's 1 minus t over 12. So what are we going to do first? By dt. Leave the 1/5 on the right, or you will not like it. That's just been my experience. So dy is equal to 1/5 y times 1 minus t over 12 dt. What is it I don't want here? I don't want the y. So we'll divide by y. Okay, so this is dy over y equals 1/5 1 minus t over 12 dt. Because you want it y equals, if you're best, if you just get the y's over there. And then somebody said to integrate. What's the antiderivative of the left side? ln of the absolute value of y equals 1/5. The antiderivative of 1 is easy. It looks horrible. What's the antiderivative of 1? T minus t squared over 2. So it's t squared over what? 24. What must happen now? Plus c. So we got 4 points on the first one. Maybe 3. I'm not sure how they did B. We can look. And the rest is C and D. How do you solve that? Because it's t squared over 2 times 1/12. This is 1/12 of t. 0? Oh, I don't know. Yes, it goes through 0, 3, right? Antiderivative of 1 with respect to t is just t. Then this is 1/12 times t. So you ignore the 1/12. What's the antiderivative of t? Over 2. Okay, Marshall, what do you do next? Okay. C. Because you get, now you guys, you could solve for y, but if you do it wrong, you're wasting your time. So always get C first. So the log of 3 is equal to 1/5. Well, that's nice. It's 0 minus 0 squared over 24 plus C. So, right, so ln of 3 is equal to C. So ln of the absolute value of y equals 1/5 t minus t squared over 24 plus the log of 3. Now what? E. Sides. Thank you for saying it. It's not terms, it's sides. So what's the left side? Absolute value of y I have a feeling I don't need the absolute value, but I'm going to use it. It's 1/5 this thing plus the log of 3. Can I bring the log of 3 down? No. No, no, no. Now, I want to check it so I know which one, because I'm going to get a positive one and a negative one. So I got the positive one here. Or I get the negative one. This one's pretty easy to decide. Yes. Because if it had been 0, -3, then it would be the other one. But it goes through 0, 3. So 3 equals e to the 0 plus the log of 3. Yep, that's true. You'll have 1. Then you may not have any. There have been some years when there haven't been any. But usually there's 1. Well, it'll be on the multiple choice. Shh. You guys, I can't hear. Abby. If you want to, I don't recommend it, because if you do it wrong, that's wrong. So it would be this. Yes. But you're not required to do it. Because a lot of people went e to this and then went plus log of 3. No, can't do that. Well, we have 1 point for separating, 1 point for integrating. So you got a point there, a point there, a point for adding c, and a point for putting the values in the right place. So that's 4. And then 5 to do that. And then the 6th point will be finding that limit. So the function found in part C, what is the limit as t goes to infinity? Well, if t is going to go to infinity, let's put in a number. Because sometimes I just don't think of infinity. Let's do, it's going to infinity. Let's do 100. So y equals 3 e to the 1/5 100 minus 100 squared over 24. Who's going to weigh more, the positive 100 or the minus 100 squared over 24? So that this is going to be a negative exponent. So if it's a negative exponent, it's going to be 3 over e to like the 100th power. So it's going to what? 0. Just try some numbers. Should we check? Should we check our points? Question. Let's check points. So we got 1 point for the 2 limits and 1 point for B. But I've seen other ones where you had to do the work. So I don't know. And they made it 5 points for solving the diff EQ, which is what we got. Hey, wait, we had 24. Oh, guess what I forgot? I lost my point. I forgot the 1/5, didn't I? It's right there. Oh, no, I didn't. No, I have it out in front. I just didn't multiply it out. Huh. So I got that, and the answer is 0. And if you didn't have an exponential function, you weren't eligible for the point. Whoa, we got 9 out of 9. These are easy to do.
You have to do the
If you want the final point, yes.
So you have to find the 3 instead.
No, I could have left it plus log of 3. It's okay. Okay, so the question is, what's this one? Oh, that's it. I have more free response, and I have, didn't mean to do that. And I have these multiple choice. Which ones do you want to do? Multiple choice? They're hard. Well, the first one's not too bad. Let's do the multiple choice. Tomorrow, or not what tomorrow, Wednesday, I won't be here, but you can work on the free response questions. You won't be here tomorrow at all. You only go to 1, 2, and 3. Physics field trip. No. Which field trip? See what? Ooh, that'd be nice. Okay, you guys, let's try these. Some of these are easy, some of these are not easy. Okay, here are the free response questions. 2009 number 4 is one that's good. It's got Euler in it. 2010, we did that one. 2011 is the waste problem. Again, the same question. And then I bet I have 2000. Oh, there's 2006. There's Euler. 2012 is the bird problem, which is just like 2011. See, now, notice it looks like a logistic curve here, but it's not logistic. A lot of people wrote down the answer to this using the logistic formula. It's not. It's separable. And they even tell you that, don't they? Hey, guys, use separation of variables. You can't separate the variables on the logistic one. You have to use partial fractions and collapsing sums. So when they say separation of variables, it's not logistic. This one really bothered the kids because I know I graded it. Yeah. This week, Wednesday. So Wednesday night we can come in and we can do some of these problems Wednesday night. There's nothing to teach. It's just coming in and doing problems. And is that it? Yes. 6 o'clock. Okay, try some of these. Try these, guys. This one's not bad. The first one's not bad. The second one is. And you've got some other ones. Now, I didn't print out the B exams, but you have them. Well, you have it right here besides. Okay. Marsha, what's the answer to number 26?
24.
Okay, Sam, what's the answer here? Griffin, you're going to get this one wrong.
Which one?
This one. Ellen, what's the answer? 3,000? No. It's not 5,000 either. What's wrong with it?
Oh, it's not 1 minus.
Hey, guys. dp dt equals kp, and then it's 1 minus p over the carrying capacity. Okay, guys, it's not in the right form. So if you factor out a 2, it's 1 minus p over what? No. 2 over 2,500. Does that give you 5,000? Check it. Does that work? What's broken? Told you. No, this winter has broken your spirits. Okay. The next one's really tough. Okay, you guys? David, did you get the right answer? D. Says the number of people on Ocean Beach is modeled by a logistic differential equation. Okay, the maximum number of people allowed on the beach is 1,200. At 10 a.m., the number of people on the beach is 200. So at 0, we start with 200. And the population is growing at 400 people per hour. Why can't it be A? It says it's logistic. What does it have to look like?
It needs to be in that form. It needs to be in case.
Well, but we could change it a little. I mean, we could take this form. And I have to find what's equivalent. There's no plus 200 there, you guys. So let's throw out A. Now I'm going to pause and let you guys figure it out. You tried. We haven't done anything yet. What's the carrying capacity? 1,200. So dP dt weird is equal to little k p 1 minus p over what's the carrying capacity? 1,200. Now what do you have to find?
I think I got it.
You got to find k. If you know something, you have an ordered pair. Yeah. You know that when time is 0, population's 200. What is the PDT when time is 0? It's 400.
Closer 400 equals.
K times, what's the population? 200. Ah. Solve that equation for K.
How do you get that?
Because the population's
Right
two.
now, this is where I.
In the beginning, we start at 200.
Right. Don't you do this though? Take out the 1 over 1,200.
No, don't do that yet. Do this. Find K first. No. Find K first.
How do you get 1,200 minus 2?
Well, let's do it this way, and then we'll get to that. Got to find K. Okay, Zach, do you have K figured out? Well, you should do it. These are real problems, you guys. What are you going to do when you hit them on the exam? You need to practice. Solve that.
Hey, how do you know DP or DP?
Because they told me. Right there, it says the population is increasing at a rate of 400 people per hour. Besides that, I don't know what else to do. Oh, could I divide by 200? Then this is 1 minus 1/6. So I want to make this easy. No, I want K by itself. 2 equals K, and this is what, 5/6?
Yeah.
So multiply by what? 6/5. You're not done. You guys, you're really loud. All right. That still doesn't look like our answers, does it? Well, let's look what the answers look like. They're 1,200 minus P. So how about if I factor out 1,200 here? And if I factor that out, I want to put a 1,200 in the denominator. Then what has to go here to make 1? 1,200 minus P. So it's 12 over 5 times 1,200 P. Once 100, so it's 1 over 500. That's still not as hard as 1 coming up.
Oh, God.
Good problems. What's the answer? C. That way? Okay, Marshall, where's your packet? No? Try the next one. I don't know. Let me look at it. Now, you guys, Not often do I have to prepare, but when I came for this lesson, I went through these problems last night because I didn't feel confident. Now, if I've been doing this for a while and I don't feel confident, what should that say about you guys? No? Oh, 2003, number 21 is easy. It's C. There's nothing to do on that one. How about 24? That's the one that's tough. That was the last released exam. And the additional multiple choice problem A, throw it out about the flu problem because we're not doing it. And the coyote problem should be okay. But 2008, number 24 is hard. I changed everything to fractions. It's kind of like what we just did. Well, you start with, okay, so this is 200. You start with the differential equation. dp dt is equal to k. And then it's p, 1 minus p over 200. So if I were to multiply that out, that's k times p minus k p squared over 200. So can we throw any of these out right away? I'm going to guess C, D, and E are not going to work. Because they're wrong. I mean, because the p squared has to be negative. Right? So we can throw those out. Okay, because the p squared has to be negative. So now you got a 50-50 chance. Well, how about if we change these to fractions? This is 2/10. This is 1 over 1,000. Let's factor it. Because I want to get a 200 here, right? So first off, let me at least do this. I don't remember how I did it. No, I'm doing A. B would look like dp dt is equal to 1 over 10 which one's going to work? You got to look at this. I got to get to 200 here. Okay. So it's 1 over 10,000 here, right? P. And then it's 10,000 minus P. Oh, 1,000. No, it's 1,000. Sorry. But that's still not going to, well, I got to get that 200 there. I'm going to have to multiply it out, aren't I? I forgot how I did it. Told you this one was tricky. I don't know. Want me to go look? No, those are what I'm given. Oh, there's mine. I know I did this. I'm missing a page. Now, oh, there it is. It's A. Okay, guys. Oh, that's not right. Minus. You know what I did? I factor out a fifth and a p. Okay, you guys? Not time to go yet. This is 1 minus p over what? 5 into 1,000 is how much? That's what A is. That's logistic. And that works. Otherwise, if you try the 1/10, that won't work. Because if I do 1/10 p minus p squared over 1,000, and I factor out a 1/10 p, I'm left with 1 minus p over 100. That's why it doesn't work. So it's A. This one we will skip. This is an additional problem. Ori and Eric, we're not done? Oopsie. Let's do the coyote problem because that's fast and easy. You've got to have k times c, 1 minus c over capital K. So you have to factor something here. What are you going to factor out? 3c. I'm left with, or do I want to factor out 9? Then I'm left with 3 minus c. I want a 1 there. So let's factor out another 3. 1 minus c over 3. So what's k? But that's not what it's asking. Yeah. I want the number of coyotes where it's fastest. Half of it. 1.5. Did I do that right? Okay, you guys, you're not going to do well on this test if you don't practice. And I picked the wrong answer because I didn't read the question. Story of my life. Okay, tomorrow have fun at your senior retreat. You should be working on AP problems. Not that much time left. 3 weeks. We will not come back and hit on this again. No, you go to senior retreat, you go to classes 1, 2, 3.
Have to go to school.